Hello everyone. Today we are going to discuss about DC circuit basic concept, and this concept will be derived from this reference, and that is the book name Fundamental of Electric Circuit, 4th edition, author Charles K. Alexander and Matthew Sadiku. Okay, today we will going to discuss mathematics only on the basic topic of DC circuit. So first of all, what is DC circuit? We all know DC means that is direct current. So in this playlist we are not gonna talk about the theory, we are gonna talk about the mathematics. So let's go to the topic first. So these are the outlines of my presentation. First of all, example 1.1, and there is practice problem 1.1 and so on. So these are the outline for this particular video. Now I am going to discuss on example 1.1. So in example 1.1, this is a very simple example. You can see here how much charge is represented by 4600 electrons. So first of all, what is electron? You already know the electrons having the charge of I can write electron what is the charge of one electron? We all know electron having negative charge, that is 1.6 into 10 to the power minus 19 coulomb. So this is the charge of one electron. So the question asked us to determine the charge of 4600 electron. So total charge will be into 4600 coulomb. So using calculator you can find this is minus 7.369 and 10 to the power minus 16 coulomb. Okay, this is a very simple problem. Example 1.1, 4th edition of Alexander and Sadiku. You can see here that this is the charge of 4600 number of electron. Okay, so this is a very simple topic, and now go further for next topic. So in this topic or in this problem, this is a practice problem 1.1. the question is calculate the amount of charge represented by 4 million protons. First of all, you have to know about million. What do you mean by 1 million? 1 million means that is 10 lakhs. So this is 1 million. Now we have to find out for 4 million. So this will be 4 into 10 lakhs. So this will be the 4 millions of proton. So the question asked us to calculate the amount of charge represented by 4 million proton. So first of all, what is the charge of single proton? One proton consists of positive charge, proton having positive charge 1.6 into 10 to the power minus 19 coulomb. So 4 million proton having 4m proton consist of, so this will be plus 1.6 into 10 to the power minus 19 multiplied by 4 million, that is 40, then 1 2 3 4 5 this coulomb. So the total charge will be using calculator you can find 6.4 into 10 to the power minus 13 coulomb. This is the charge of 4 million protons. This is also the very simple problem. Hope you all understand. Now go to the next topic or next problem. That means that is example 1.2. Example 1.2. So what does it says? The total charge entering a terminal is given by Q is equal to 5t sine 4 pi t millicoulomb. Calculate the current at t is equal to 0.5 second. So what we should find? We have Q and we have to find the current. So we know I relationship between current and charge, I is equal to dq by dt. Okay, so now insert the value of q in this equation, that is d by dt, and q that is 5t sine 4 pi t. Okay, so now what will be the unit? The unit of charge here is millicoulomb and time is second, millicoulomb per second. So now we have to differentiate this charge. So this is a very common differentiation. You can know d by dt a dot b, it can be represented as dA divided by dt, where b is constant. Again take a constant, then dB divided by dt. So this equation is implemented using this simple formula. So we can write d by dt. So we can take t as constant, that's why t outside of d by dt. Then here is 5 sine 4 pi t. Then again we have to take 5 sine 4 pi t as constant, 5 sine 4 pi t as constant, but t should be differentiated in respect to d by dt. So you can see here, this is t will be here, then this is the very simple differentiation. We are differentiating sine, we can get cos, cosine, and this 4 pi also come outside. So another differentiation will be here, this 4 pi t. It's a very simple topic for differentiation. So you can see 5 into 4 pi cos 4 pi t, and here will be 5 sine 4 pi t. Here will be dt by dt will be cancelled, 5 sine 4 pi t. Okay, now this will be 20 pi t, 20 pi t cosine of 4 pi t plus 5 sine 4 pi t. Okay, now the question says we have to calculate the current at time t is equal to 0.5 second. So t is equal to 0.5 second. Okay, so using this, here will be millicoulomb per second, this will be milliampere, this will be also be milliampere, this will also be a milliampere. Okay, now we have to insert time. Okay, so insert time t is equal to 0.5 second. So we have to insert 0.5 second here, here, and here. Okay, so it will be 20 pi into 0.5 into cos of, it will be 2 pi. Okay, then 5 sine, also it will be 2 pi. So total equation, sorry, this will not be t, this will be I, this is not t, this is I. Okay, this is a current at 0.5 second. So here will be 10 pi into cos 2 pi, that means cos 360. What does no, sorry, yes, cos 360. Cos 360 means 1. Okay, cos 360 means 1, and here 5 into, sorry, 5 into sin 360, but sin 360 does, it will be 0, so here will be 10 pi. So calculating 10 pi, we get 31.42 milliampere. So this is the answer for example 1.2, 31.42 milliampere. Hope you all understand that. First of all, I repeat myself. So changing the color. So here we know I is equal to dq by dt, then q given in equation in question. Now we use the equation of this. This is the equation for differentiation, very simple equation or simple formula you can say. Now we implement this, and implementing this we got this, but we need to calculate the current for 0.5 second. That's why we use 0.5 in every t. In every t we use 0.5, and finally we got this 31.42 milliampere. This is the answer for this example 1.2. Okay, then practice problem 1.2. This is very similar to example problem 1.1. So similarly we have to find the current at t is equal to 0.5 second. We know I is equal to dq divided by dt. Okay, so now t by dt, what is the value of q? This is the value of q, 10 minus 10 e to the power minus 2t. So using the formula of differentiation, we have to separate both of them. So it will be like this, 10 e to the power minus 2t. So what will be the unit? Unit will be, the unit of charge is millicoulomb, and then here is second, millicoulomb per second. Okay, now what will be the differentiation of this constant term? It will be 0, and now differentiating this, as you all already know, the differentiation of exponential term will be like this, e to the power minus 2t. The unit will be milliampere. So this will be 20 e to the power minus 2t milliampere. But we have to find the current at t is equal to 0.5 second. So current I at t is equal to 0.5 second. Okay, so what will be the current? 20 e to the power minus 2 into 0.5. So current term already only present here, that's why we use this. So it will be 20 into e to the power minus 1 milliampere. Using calculator you can find 20 into 0.36 maybe. Okay, yes, 0.3678 and milliampere. So the final current will be 7.357 milliampere. Okay, so this is the very similar of example 1.1, same as example 1.2. Hope you all understand these two problem. This is the common differentiation related problem. Now we'll go to the common integration related problem. So the question says, determine the total charge entering a terminal between t is equal to 1 second and t is equal to 2 seconds if the current passing the terminal is I is equal to this. Okay, so what we have to find? We have to find total charge. to find the total charge. So we know the very common formula I is equal to dq divided by dt. But if we modify this, I into dt is equal here will be dq it will be dq. Okay, it will be dq. Now we need to find the total charge, so we have to integrate on both of sides. This will be I dt integration of dq. So what will be the final output? Output will be q integration of I dt. So we have to find charge by the integration of current. So now we will find the total charge q. Q is equal to integration of I means 3t square minus t. And what are the limit? Say here t is equal to 1 second to t is equal to 2 seconds. 1 second is the lower limit and 2 second is the upper limit. So 1 is the lower limit and 2 is the upper limit. So here will be dt and unit will be coulomb. Okay, now this is a simple integration formula. Use 3 t to the power 3 divided by 3 minus t square by 2. Hope you all know this integration formula. If you don't know, let me remember you. Integration of t square dt, it can be written as the power 1 will be added with power, the whole power divided by this. So it will be t to the power 3 divided by 3. Okay, so we use this formula here. So using the simple calculation, this 3 will be gone. Now 2 to the power cube is equal to 8 minus 2 to 4, 4 by 2, 2. 8 minus 2 minus 1 minus of half. So it will be 6 minus half. This will be 5.5 coulomb. So this is the answer for example 1.3. Hope you all understand this. Now go to the problem, that is practice problem 1.3. So this is similar to example 1.3, but there are some issues with this. So first of all, you can see here what is the question asked. The current flowing through an element is this I is equal to 2 ampere. This current will be 2 ampere. Between the range, time will be greater than 0 and smaller than 1 and 2t square when time is greater than 1. So the portion of question is missing here. The question is calculate the charge entering the element. I am writing over here. Calculate the charge entering the element from t is equal to 0 to t is equal to 2 seconds. So this is the missing part or missing question. So now we have to find charge. So similarly, before the previous, just before this example or practice problem, we have determined q is the integration of I of dt. So we will use this formula to find charge. So there are two limits. First, this 2 ampere current will flow when time is greater than 0, smaller than 1. So lower limit 0 and upper limit 1, and it will be 2 dt. Similarly, and 2t square, this term will be t greater than 1, but we have time limitation up to 2 seconds. So first cycle occurs 0 to 1, so second must be occur from 1, and maximum limit is 2, 1 to 2. Okay, now this is the simple integration. This first line is very important, and there is very simple integration. It will be 2t, and limit will be here 1 0, and similarly 2t cube by 3 divided by this is 2 and 1. So use this 2 plus 2 by 3 into 8 minus 1, 8 minus 1. Just calculating, we find 6.667 coulomb. So don't forget to give the unit. So this is a very simple problem again. This is a practice problem 1.3. So hope you all understand this. This is a very simple problem. We started to cover all the mathematical problem in very simple manner. Hope you all enjoy this. Thank you everyone.